Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. This video shows the VisualCAM 2016 for SolidWorks MILL module being used to machine holes and pockets in an existing part blank. Without further delay, we invite you to sit back and enjoy the demonstration.
Our VisualCAM plugin for SolidWorks works in SolidWorks 2010 all the way up to 2016. And this is a gold certified CAM partner product for SolidWorks. So if you have SolidWorks 2010 and newer versions all the way up to 2016, our VisualCAM plugin will work directly inside of SolidWorks. So what I'm going to do here is first load the part that you emailed us in here. So I'm going to go ahead and just drag the part into it, and looks like this is the file that you sent us for the demo today, right?
Yeah.
Okay, great. So I got the part loaded, and as you can notice here, as you load the part, you'll automatically see the VisualCAM tab appear in your command manager, and also the VisualCAM's browser window appears right next to your feature manager design tree, so you can switch back and forth.
So this is an add-on for SolidWorks actually?
That is correct. This is an add-on for SolidWorks.
Okay.
So I'm going to demonstrate to you the add-on for SolidWorks, and also we'll go with the standalone product as well. Okay?
Yeah.
All right, great then. So we got the part loaded in here. And by looking at this part, it looks like your Z-axis is not oriented from the orientation you're probably intending to mill this part from. Is that correct? So you would like to set the Z-axis to be normal to this face. Is that right?
Yeah, you can do that.
Okay. So currently your Z-axis is basically in the same orientation as how you have it established in SolidWorks. So the coordinate system for machining is by default in the same orientation as you have it defined in SolidWorks. So the first step is after we load the part, we want to establish the coordinate system for machining. So in order to define the coordinate system for machining, right on your machining browser, you click on Machine, and the very first tab here is the Machine Tool Coordinate System. And you can now select the orientation in here. So in this particular case, I can use the spin controls, and I can either say rotate it about 90 degrees about the y-axis. You'll now notice that your Z is being rotated by 90 degrees about the y-axis, so it's being normal to the face. Now alternatively, you can also use select surface and just pick a face or a surface on the part, and it'll use the normal orientation of the surface. And if you need to rotate it to flip the normal direction, you can either flip the normal for the face in SolidWorks, or you can just rotate it in here to set the Z-axis. You could even use a active plane or even a planar sketch to set the Z-axis orientation. So once you've established your orientation of your Z, X, and Y, as you see it right here, the next step is you go into the machine tool definition to define the machining process if you're going to be doing 3-axis, 2-axis, 4 or 5-axis machining. For 2 and 3-axis, we would select 3-axis, and we also have options for 4 and 5-axis machining. Our mill module is offered in 4 different levels or configurations. We have standard, expert, professional, and premium. The standard includes 2 and 3-axis machining. Do you have any questions so far?
No, go ahead.
Okay, great. The next step we want to do is select the post processor that you'd like to use to output G-code for the part you're going to be programming. So you would click on post, and you can select the post processor from the list of posts in here. So I had my post processor currently pointing to a different folder in here. So what I'm going to do here is basically point it to the correct folder where it needs to be. By default, it should be pointing to the 2016 folder of VisualCAD. So I'm going to go back in here and change the path and select the post processor. Would you be able to tell us the machine tool that you're going to be working with?
It's going to be Fagor.
It's a Fagor. Okay. All right. So let's go down the list, and we have several different posts for Fagor. Do you know if it's any one of these 80-20, 80-50, 55-70, or just a generic figure controller?
It's 80-37 on the lathe and 80-55 on the mill.
Okay, so we're going to pick the 80-55 for the mill, and you can specify your file extension for Fager. Does your Fager read .nc or is it .pim for the file extension?
Well, we didn't get to that point yet, so that's why.
Okay.
I think NC for now it's okay.
Okay, so we can do NC, or if you need to add certain Fager machines, use .pim. You can click on Add New, and you can add a new extension and call it .pim. So that's how you can add newer extensions. Or if you'd like to use NC, you can select .nc.
Okay.
All right. So the next step is, since we changed the orientation of the setup is flagged dirty, so we just right-click and regenerate. So that'll update the setup to ensure that the orientation for machining is defined, so it's normal to the space right there. We are now ready to create the stock geometry in here. So we can click on stock, and we can define the stock either as a box or a cylinder stock with the standard configurations. Now with the Pro, you can also define part offset stock. You can do extrusion, stock by extrusion, also stock by selection. Would you be starting out with a rectangular blank or a cylindrical blank for this part?
Cylindrical.
Cylindrical. So let's go with the cylinder stock, and then you can specify the radius to be about the Z-axis, and when you hit copy model bounding cylinder, the system will automatically compute the minimum stock size that's required to mill this part. Now the radius, what you're looking at here, is about 5.4375, and the length, would you like to specify a specific dimensions for the stock, or would you like to go with what's being recommended by default?
I mean the stock, the bar stock, they have round numbers, so I guess the radius would be 5.5.
So 11 inches, no? Yeah.
Yep, radius is 5.5, which is diameter is 11 inches. And how about the length?
The length, I cannot read the number, it's too small there, but it's
0.875, the length.
well, we would make it, I think they have a minimum of, what is it, 1 inch or 1 1/8 for the cut.
Okay,
So let's
would
put
you
it
like
at
to
1
put it
inch.
1 inch? Okay, great. So I'm going to define the stock to be 1 inch. And now if I click on stock visibility, you'll see that the stock appears on top of the part right there. So the next step is to align the stock to the part. So you could use align, and you have the option to align the stock to the top face of the part, or to the mid, or to the bottom. Would you like to have the flush to the top face of the part, or would you have it flush to the bottom so you can face all the material off the top?
Not the top, yeah, would be the top.
With the top. Okay, so basically the top of the part is flushed with the top face of the part. Am I correct?
Well, that won't leave any allowance for just that face to the machine. Can you put it in setup?
Yeah, for the Z, I can specify. This is basically aligning the stock to the part. So we would then establish the origin. So since your part is, 0.875 thick and the part is 1 inch, so do you want to leave material at the bottom, or do you want to remove the material off the top when you're doing a facing operation? So to bring it down to the actual thickness of the part.
We'll have to face both.
You'd like to face both sides?
Yes.
Okay, so we would want to put the Z to the center, and also we want to do X and Y to the center as well. So if you now take a look at the stock and the part from one of the end views right here, you'll notice that there's material being left on the bottom and also on the top.
Yeah.
Okay? All right, so the next step here is we're now ready to select the material. So you can select the type of material you're going to be cutting. So if it's going to be aluminum or steel, or what kind of material do you plan to use to cut this part out of?
I think you have 4140 or 4130.
Okay.
But
we have
4140, 4130, I have both of those steels right in here. So would you like to pick 4130?
No, go with a mild steel like 1045 or
1030?
Yeah.
1030, yeah.
Okay, we'll do that, and then we'll select OK here. Now if I display the texture, you'll notice that the texture of the material is also applied to the stock blank. You can toggle the display of the texture in here by just clicking on Show or Hide Texture Visibility. The next step we would want to do is establish the 00, the work 0. So we would go to work 0 in here, and we would like to specify your XYZ origin. So here you can specify where would you like to put it. You could say you want to put it to the start blank, and if you want to put it to the top face, you can pick higher Z, and you want to leave it in the center, you pick center. So your XYZ origin will now be set to the top face and then to the center. Would you prefer to put your XYZ origin right at the top and center?
No, that's fine. Center is okay. Yeah.
Okay, top of the start blank and then the center, right?
Yeah.
Okay, we are now ready to program toolpaths for it. Now, since several features on this part is prismatic, so you would probably be able to use like 2.5 axis milling to program it. And then if you also want to program this fillet that you have using a 2.5 axis milling, you can probably do it if you have a tool that's exactly matches the radius, right?
Yeah.
Or you can use a 3-axis toolpath for programming it. Now let's take a look at how we can go about programming this in here. The first step is we want to face it down. So let's go ahead and define some tools. I'm going to delete the tools I currently have, and we'll go through the process of defining the tools. So we have tools of type ball and mills, flatten mills, corner radius, tools of type engraving, chamfer, taper, thread mill. We have tools for face milling, dovetail, fillet mill for doing corner rounding. We have lollipop cutters. We have user-defined tools, drill, center drill, reamer, tap, bore, and reverse bore. All of these tool types are available across all our configurations. Now, to define a tool, you can select the tool type. So if you want to do a facing operation, you would want to probably use a face mill. You can specify the tool. You can specify a tool diameter. I can put in like a 2-inch diameter. Specify the flute length in here. Specify the shoulder length. Specify the overall tool length. You can set the shank diameter. And then you can specify this tool name. I can call it face mill.
Okay, I'm sorry, but we were thinking about turning the part and milling only the slots and drilling the holes.
Okay, all right. So if you're looking to just do the slots and drilling the holes, right? So we can do that in here. So let's go ahead and change the tool type in here. Do you know what size end mill you would need for the slots?
I think the slot they have an inch, right? So
Maybe you want to go with like a 3/8 end mill?
a 3/8, yeah, that would work.
Okay, we'll call it end mill 3/8. And we'll put in the tool diameter as 0.375. And we can go to the properties to set the tool number. So if you have an automatic tool changer, you want to make sure that you assign the tool number that matches your tool changer. You can specify the coolant to be flood, mist, or through. And when you go to feeds and speeds, since you already selected the material and the tool material, the system can give you recommendations for feeds and speeds right in here. If you change the tool material, the feeds and speeds will change. If you change the surface speed, if I change this to, let's say, 250, you'll notice that your spindle speed and the cut speed rate automatically changes.
Yep.
And selecting Save as New Tool automatically updates this information, and Save as New Tool creates the tool. So we have an end mill 3/8 defined. Now, since you're going to be turning this part over to bring it down to the shape of the part, we could go back and redefine the stock in here just to be a cylindrical blank, because it's already going to be turned, these features, right? So we can change the stock definition in here to go back and just leave it the actual size of the part, since we're going to be doing only milling operation on it. And we can go back and again reset the work 0. You can change it right here to just put it to the top face right there. So let's program these slots in here and then the holes. Now the holes that you have are 0.67 in diameter. So we can probably use the same 3/8 cutter, or if you want to use a 1/2 inch end mill, we can use a 1/2 inch end mill for it as well. Would you prefer using 2 different tools, or would you want to just use 1 tool for all of it?
No, we would use the same one, so we save the tool changing because it's manual tool changing.
Okay, so let's go ahead and program a 2-axis, and let's do a pocket operation in here. So select pocketing. Now, there are several different ways you can select the features. We can use select curve regions and go pick the face edges by right-clicking on this edge, and you can say select tangency for each of those pockets. So you're using all the SolidWorks selection tools that are available in here to basically pick all of the features that you're trying to pocket. So you have those 4 pockets selected right there, and they're all listed in here. The next step is to specify a tool. The feeds and speeds are automatically loaded from the tool. Now when you take a look at the clearance, you can see that the clearance is automatically defined based on the part and the stock. So that's the safety plane for all your transfer motions. Next, we'll go over to the cutting parameters, and you can specify the tolerances for the pocket operation. You can leave some side stock. You can go back, and if you want to do a profile cut to finish it, you can specify to leave maybe like 15,000 side stock. You can pick your cutting direction, your step distance, and in your cut levels, you can pick the depth. So the feature what you selected is at the floor of the pocket. You can say it's at the bottom. And for the total depth, I'm going to use this pick option. I'll pick the top face right in here, and then pick the floor. So the total depth is defined also as 3/8. Now for this total depth of 3/8, if you want to rough it or pocket it in 2 steps, you can specify your depth per cut right in here, 2 or more steps. You could then specify your entry and exit parameters, and then select generate. And there's your pocket toolpath. Do you have any questions?
No, that's fine.
Okay, so now we'll go ahead and run a verification. So go to the Simulate tab. We'll select the operation and then hit the play button, and there it is. There's your simulation. Now, if you're going to be looking at our Pro configuration, one of the nice features in the Pro configuration is what we can do is we can actually go ahead and create what is called stock from selection. So for example here, you typically, your stock blank, what you're going to be starting with, would have these features suppressed on it, right? Am I correct? So this is the stock blank you're going to be typically starting with, right?
Yeah.
So in the Pro, what you can actually do is you can actually select these features, select the features on the part, and define your stock using stock from selection. So your stock is actually going to be exactly what you have designed in here. So once you define the stock, you can see that the stock is defined based on selection in here. You can also define the stock from selection. So what I'm going to do here is rebuild the part and then go back and define the stock from selection. So the stock would be actually the true representation of what your part here is. So you can select those features in the tree and define a stock from selection. So that will basically actually be the true representation of the part, what it would look like when you're starting it out. So the reason we are seeing some artifacts, it could be possible that the order in which these are in the tree, so I'm just going to move it up in the tree right here. And I'm going to go back, save the part. And let me just try to reload it, and then I should be able to define the stock for it from using stock by selection. So let's go back and redefine the stock using stock from selection. And we should be able to program the toolpath. So let's delete it. Let's go back in here. Let's select the 2 features from the feature tree and then define a stock using stock from selection. And there it is. You see that, sir? Nice and clean. Right? Now after you define the stock, you could go back and unsuppress these features. And I'm going to go back and move this chamfer operation right below it. There it is, right? That's your part right there.
Yep.
Now, we'll go back to this pocketing operation in here, and we'll make sure we reselect the region. So we can either select the face edges, or I can use select flat, and just I can pick the floor on each of those pockets. So I selected this floor on the pocket, accept it, and generate it. There's our pocket toolpath. So now when you run the simulation, what you're simulating is based on the turned out piece of blank you're starting out with. So the Pro configuration allows you to define the stock from selection. The next step is you want to pocket these holes as well. The holes what we have is 0.67. So there's a couple of ways to program it. We can use hole pocketing or two-axis pocketing or hole profiling. So if you'd like to do a hole pocketing operation, you can go to two-axis and use hole pocketing. And you can basically select the features. I can just go click through these hole features, select them, accept the selections. There they are. And you can use the same tool. Beats and speeds are automatically set. Your clearance is set to automatic. You have your cutting parameters. You can either specify the hole diameter, or you can say use arc diameter for the holes. So automatically the system can figure out the diameter. For the depth, I can just pick the top face and then down the bottom edge. So the depth is 5/8, as you see it right here. And now you can specify your parameters for the hole pocketing operation. You can specify the number of levels for the cleanup pass. I could say I would like to have only one level of the cleanup pass, or if you want to do multiple levels, you can do multiple levels. Under your entry and exit, you can specify the helix diameter in here. You can specify your parameters for the helix height and pitch. I could say I want to go an 1/8 inch as the helix pitch, and then hit generate. And there's your hole pocketing toolpath right there. That's pocketing each of those holes. If you want to change any of the parameters, you can modify it, edit it. You can specify all of the parameters. You can change your step over distance for the spiral path. And there they are. And now we can go ahead and run a verification. Go to the Simulate tab and hit the play button, and there it is. So once you have the toolpaths programmed, you can post-process this to your machine. Before you post-process, you can also take a look at the estimated machining time by selecting information. So based on the parameters we put in, that's your machining time estimate. And then right-click and then select Post. And you can specify the file name. By default, it'll post in the same folder where you had the part located. And your posted file automatically appears in a notepad. And there's your posted G-code, which can then be transferred out to the machine. Any questions?
Yeah, if we want to have, if we have some clamping to hold the parts down, can we draw it somewhere there to see it and then make sure there's no collision when we do the simulation?
Yeah, you can model the clamps in your CAD and then bring it in. So when you run your simulation, you can see where they are during the simulation. So you can ensure that as the cutter transfers over, it's not running into any of those areas.
Yeah, because so we can show the operator how to clamp it, so we make sure that the clamp is not in the way of any of these features, right?
Right. You can probably bolt it down from the center or maybe use clamps from the side, so depending on how you want to clamp it. But here what you're looking at is the toolpath is generated based on the part geometry, what's visible in here. So if you have other features that are, that are around this part, it'll take into account those features of parts for the clearance heights to transfer over.
That clearance, we can change it, right, and make it higher.
Absolutely. I can change it right in here by going to clearance. I could say go maybe an inch above the maximum height of the stock. So you can see that it's 1 inch above the maximum height of the stock, and now we can generate it. Now the clearance is automatically changed.
Okay.
There it is. And then when you save the part in SolidWorks, automatically all of the machining operations get saved to the same part. So when you post it out, the only extra file, additional file you're creating is your NC file. And all of your machining operations are saved in here. So if you have parts that are similar to these, you can save these out to a knowledge base. And you can specify a folder where to save it. And when you have parts that are similar to these, where you would like to reuse the same workflow of operations, you can just load those operations from the knowledge base to program it.
We hope you enjoyed this addition to the MecSoft demonstration series. For more videos or to download and test drive any of our products, feel free to visit us online at www.mecsoft.com. Thank you.